Welcome to my Cisco's Routing and Switching Essentials lab review. In this course, we're looking at lab 8227, configuring OSPF version 2 as a single area network. I already loaded up my packet tracer and I'm looking at my lab steps now. So what I want to do is find my mouse. Okay. Keep in mind when we do this, we're looking at what networks does my routers know about. So router 1 knows about these guys. I just do a little snippet. So router 1 knows about these guys right here. Router 2 knows about these guys right here. And router 3 knows about these guys right here. So let's go ahead and let's do that portion first. So I got a notepad document open. So R1, R2, R3. So let's do R1 first. We know about what networks? 172.16.1.0 /24. We know about 172.16.3.0/24. And we also know about 192.168.10.4/30. Oh, that one is a typo, because that's 3.30. For router 2, I know about 172.16.2.0/24. I also know about 172.16.3.0/30. Last, I know about 192.168.10.8/30. Alright, so let's move on to router 3. Router 3 knows about 192.168.10/8, 10.8/30, 192.168.10.4/30, and lastly, it knows about 192.168.1.0/24. We're just looking at the network IDs. So once we have that part, figuring out the networks is fairly simple. So we've done almost all of that already. So next we're going to make sure that our process ID is ID 10. So how we do that is router OSPF 10. We're going to use router ID and a specific router ID for each of them. So router -ID. So that will manually set it to that ID. All right, we want to network address for each interface. So we did the networks. We just have to tweak them a little bit because we have to make them in the network statements. So we need to actually add the word spelled correctly, network in front of it. So it shows our network. So that's one part. The next part is we need to actually have these slash numbers. We need to do them as wildcards. Remember, wildcards are just the inverse of the subnet mask. So you can always do the /24 as a subnet mask and then do the inverse of it. Helps if I don't fat finger anything. All right, and so we are almost done with that part. So those is partially the network addressing. Because we're doing OSPF, we have to tell it what area it's in. They are all in area 0. Okay, so that part's done. Lastly, we need to set passive interfaces. So how we do this is we type in the word passive -interface, and what interface do we actually want to make passive? All right, so I'm going to go up to Options, Preference, Always Show Port Labels. So we want to make our LAN interfaces passive. So for R1, it should be gig 00. Because I don't want to have to keep retyping passive interface. For R2, it should also be in gig 00. And for router 3, gig 00. So I'm going to move that off to the side. And now we actually just have to input it on our devices. So let's hop on R1, get to our CLI. To make this a little bit faster, I'm going to type enable conf t. That way I can just copy and paste this entire thing. Router 1's done. Router 2 is done. And router 3. Oh, gotta get enabled in there too. And it's starting to form the adjacencies. So let's go ahead and let's do part 2. Let's verify each PC can ping one another. Command prompt. Ping. I'm going to ping PC2 first, 172.16.2.2. The first one should time out as they try to find one another. If it times out, just ping it again. All right, let's ping PC3. 1.2. Again, the first packet should time out. But we just verified end-to-end connectivity. Oh, you know what? Just for completeness sake, let's make sure that we verify the routing table on each router. Show IP route. Here are the routing tables that we've done via OSPF. Let's hop over to router 2. Show IP route. Again, there are the ones that we learned via OSPF. Let's hop on R3. Show IP route. And there again, we have our routes we learned via OSPF. And that way we have verified all portions. Let's go ahead and grade the activity. Let's double check. And everything is green, so we are good to go.